Standards are the backbone of engineering, guiding everything from steel buildings to pressure vessel installations. Whether you fabricate a pipeline or carry out maintenance in heavy industry, your work must follow recognized standards. However, two standards often confuse engineers worldwide: AISC and ASME. When should you use AISC? And when should you use ASME? Why do they exist? And how do they make your project safer? In today's video, we will decode all of this in simple language. So sit back, grab a cup of tea, and let's explore the engineering world of AIC versus ASME. Before we jump into AIC and ASME, let me ask you a question. Imagine you are building a steel structure in India, and someone else is building the same structure in the US. Should both follow the same rules? Ideally, yes, because engineering shouldn't change based on location. Standards bring three major benefits: safety, uniformity, and quality and reliability. A bridge should never collapse, a pressure vessel should never explode, and a pipeline should never leak. Uniformity ensures everyone uses the same formulas, weld sizes, material grades, and connection design rules. Quality and reliability mean clients trust your work, inspectors approve your design, and projects become more durable. So now that you understand why standards exist, let's decode the first one. AIC stands for American Institute of Steel Construction. If you work in civil engineering, structural engineering, or steel fabrication, this name is your daily partner. Simply put, if you design any structure made of steel, AIC gives you the rules of the game. AIC covers steel buildings, bridges, industrial plants, platforms, and pipe rack structures. It also includes conveyor galleries, crane girders, and steel connections. AIC tells you how much load a beam can take, how to design columns and trusses, and how to size welds and bolts. It also specifies how to calculate buckling, what material grade to use, fabrication tolerances, and erection guidelines. The most famous AIC book is the Steel Construction Manual, often called the Gita of structural engineering. Have you ever wondered how structural designers know exactly which section size to use or which bolt grade is safe? Where do they get those formulas? Yep, AIC provides all of that. Now, imagine a different scenario. You are working in a refinery, a chemical plant, or a power plant. Here, you deal with machines that operate under pressure, temperature, steam, gas, or fluids. For this environment, we use ASME standards. ASME stands for American Society of Mechanical Engineers, and it focuses on the safety of mechanical equipment. ASME covers boilers, pressure vessels, heat exchangers, pipelines, and gas cylinders. It also includes storage tanks, valves, flanges, and HVAC pressure components. The most important document is the ASME Boiler and Pressure Vessel Code, or BPVC. This giant rulebook ensures your mechanical equipment does not fail dramatically. Pressure vessels can explode if designed incorrectly, boilers can burst if material fails, and pipelines can crack under wrong pressure. ASME tells you minimum material thickness, testing requirements like NDT and hydrotest, and welding procedures. It also covers design calculations for pressure and temperature, relief valve sizing, and inspection intervals. So, in one line, ASME protects equipment while AIC protects structures. Here is the most important part engineers must understand. If you are designing a building around a pressure vessel, do you use AIC or ASME? The answer is both. AIC is for the steel frame around equipment, platforms, handrails, columns supporting equipment, pipe racks, walkways, and a building envelope. ASME is for the boiler, pressure vessel, heat exchanger, piping joints, valves, flanges, and nozzles. Imagine a refinery. The structure holding the pipeline uses AISC, but the pipeline itself uses ASME. The vessel sitting on the structure uses ASME, but the steel saddle supporting the vessel uses ASME, and the beam holding the saddle uses AISC. Engineering is teamwork between these standards. Let's make this real with examples. For building a steel factory, columns and beams follow AISC, while the boiler inside the factory follows ASME. The gantry girder follows AISC, and the chimney shelf follows ASME. For a pressure vessel on a platform, the vessel shell, nozzle, and support legs follow ASME. The platform around it, handrails, ladder, and anchor bolts all follow AISC. For a pipeline running across a plant, the pipe, flange, and bolt follow ASME. The pipe rack structure and expansion loop support follow AISC. For a heat exchanger replacement, the tube and shell design follows ASME, while the mounting structure follows AISC. The lifting lugs follow ASME, and the lifting beam follows AISC. See how smoothly both work together? Another key difference is in fabrication and inspection requirements. AIC fabrication focuses on dimensional tolerances, ball tightening, welding quality, structural alignment, and paint and corrosion protection. ASME fabrication involves radiography, ultrasonic testing, hydro testing, stress relieving, and pressure testing. It also includes rigorous documentation requirements like WPS, PQR, and MTR. ASME documents are often thicker because pressure equipment needs more rigorous verification. If you work in mechanical maintenance or civil engineering, understanding both standards gives you a big advantage. Benefits include picking the right standard instantly, avoiding costly redesigns, and improving safety and reliability. You become more confident in field discussions and handle audits and inspections professionally. If you want to grow into leadership roles like maintenance head, project manager, or design lead, this knowledge is not optional, it's essential. Let's recap everything in 20 seconds. AIC is for structural steel design and construction. ASME is for pressure equipment and mechanical safety. AIC protects the building, and ASME protects the equipment. Both work together to create safe industrial plants. Understanding these standards makes you a stronger, safer, and smarter engineer. If this video helped you understand AISC and ASME, hit like, share it with your engineering friends, and subscribe to Simple Gyan for more powerful mechanical engineering knowledge delivered in simple English. Thank you for watching. See you in the next video.